So today I'm going to take the opportunity to walk you through one of the applications I built just like a minute ago. Get started. So first, what we do is we create a repository. So this is my new organization, for the light-codegen blockchain. You can just create a new repository by clicking this button. I got a new repository created already called light-codegen faucet. So this is the service I'm gonna start to build. Basically, it's a faucet website for the testnet, so that users can go to this website. Go to a website, call this API to populate some of the tokens to his or her test address. So once you have the repository created, you can select the repository name, public or private, whatever, and you can have a README, and you can select license, whatever. Once you create this repository, you can check out this empty repository to your local. So the next step, we will create a model config folder, and let's say we create a new project using OpenAPI as example. So we go to the test REST folder in model config from a network. This is the repository contains all the specifications and the configuration for light-codegen. You go to OpenAPI folder, and you can create a new brand new folder to host your light-codegen information. In the development branch, I've already created this new folder called light-codegen faucet. So you can, if you see here, I have files already there, but I just created minutes ago, 40 minutes ago. So what we need in this folder is you have README to specify, okay, what this project for, and what's the command line to generate this project. Normally, this is very easy for user to follow if they want to generate on their own. And the next, you need to create a config.json. This is the config file to tell light-codegen how the new project is going to be scaffolded. If you look at the content for this particular project, the name is faucet, version, group ID, artifact ID, and all the root package, handler package, and the model package. Basically, this is how the configuration we need to put in to control how the package is generated. And then we have this override handler, test case, override model all set to true for the first time, so that you can generate all the handlers and the test cases as well as models for the used by handlers. Port number, we have HTTP disabled, but HTTPS and HTTP2 enabled, listening to A443. Enable registry. So we tell the service to register itself to the centralized registration, like console or Zookeeper. We don't have database. We don't have H2 for testing. We don't need to call any other services. So client, we don't need a client for this service as well. Docker organization, we still use network. So this is a free Docker Hub account. So once we have this done, we need to add it to create a specification for this particular API. In this example, I'm using Swagger editor because this is really simple. So if you look at this, now in most cases, I'm just copy from another API and make modification using Swagger editor. So you can see we have title, we have server URL, and we have path. So we have faucet address, and the return example will be like a light-codegen this number. And this is for this is a post request. You want to force a certain amount of coins to your address on the testnet. There are another endpoint, get snapshot for an address in the testnet. So you can just pass in using the get, pass in this pass, force it address. You can get, the example would be just like, say, for this currency you have this amount. So this is the Swagger specification. Once the specification is done, you need just export as YAML and export is convert as a JSON, and this will those two files will be in your download folder, and you just need to copy into your local model config folder. Those are the two files I just copied and checked into the GitHub. So you have README, you have config, you have a specification in both JSON and YAML. So once this is done, what we need to do is we can run the light-codegen. So let's do this. Go to the network. I have almost everything over there, and you can just copy this command line. This 3 command line, and you just run from here. So this will generate the project in the folder called TMP Taiji Faucet folder. So the reason I'm not generating this into the checkout folder is because most time I generate into a temporary folder so that I can do a full test comparison to see what has been changed and then merge the project into the repository. This is the safest way because sometimes, like if you use generator, some handlers and test cases might be overwritten. So if we go to this folder, we can basically compile and start the server. So the server is up and running. Let's open another terminal and try to access the server. So this is the command that I can access the server. The server is listening to 8443 and we use faucet, and this is the account number. It's a fake account number, not the real one. But if you click this, you can see we got the response exactly like as we defined in the specification as example. So this is the example we return. So this concludes the steps. You create a brand new project from a specification to code generation. I will create another video later on just to show you how to complete this project and deploy this to a Kubernetes cluster. Thank you. Bye.